Good Friday morning. It's the beginning of the long holiday weekend, and we do have some trouble brewing in the southern parts of the Gulf of Mexico. The center right now of the storm is over the Yucatan Peninsula. That storm center being over land is an issue for the time being, but as you can see with the probabilities of the storm developing, it's not going to be a problem for very long. 90% chance of this becoming our first named storm of the 2018 Atlantic hurricane season, Alberto, within the next 2 days. If it doesn't happen then, it will happen in the next 5 days. It shares that same probability at 90%, despite the season actually starting a week from now on June 1st. Here's how it looks on satellite imagery. Much healthier and better organized than what it looked like just 24 hours ago, despite the center of the storm system being actually over land. Land interaction and tropical systems do not mix well. Tropical systems get their energy from the warm ocean waters, but it's not expected to stay here forever. It's going to be drifting off towards the north. Once it hits those warm waters of the Gulf of Mexico that are over 80 degrees Fahrenheit, we'll start to see that generation of convection or thunderstorm activity around the whole center. Right now, it's just mainly based off to the east. And that's for good reason, because we have strong wind shear. Wind shear is also something that destroys tropical systems, but this has been able to kind of hold it together, at least as an invest, for the last couple of days, despite 20, 30, 40 knot winds aloft that's blowing and displacing the convection, the thunderstorm activity, well off to the east of the actual center. So we would need that convection to start developing all around the center, having a symmetrical system and a closed low to get that storm upgrade to a tropical depression or a tropical storm or a subtropical depression or tropical storm. We'll talk about the difference in those in just a second. Also, that wind shear is bringing in some extremely dry air indicated by the brown shading here, but notice the track of which it's taking. It's moving into a much moister atmosphere, and certainly on the eastern flank of the storm, it's much more moist in that atmosphere there with a lot of heavy thunderstorm activity. So let's decipher the difference between a subtropical and a tropical storm, and it mainly has to do with how the storm derives its energy to kind of organize and strengthen. With subtropical storms, it pulls its energy from cooler processes aloft in the atmosphere. Also, the core is in the process of going from cold to warm. The winds are also more spread out with a subtropical system. That's what we're seeing here. And it starts to get its energy in the starting phases from latent heat. And that's a process from the warm ocean waters. The water evaporates and then condenses into liquid water, and it gets its energy from that process, that transition to the phases from gas to liquid. And if the winds are over 39 miles per hour, then it'd be categorized as a subtropical storm. Now, if it does have a completely warm core system, we call this a tropical storm. And that's when it's actually based over warm waters for several days, and that gives it that warm core, becomes a tropical storm. The thunderstorms begin to develop more around the center, and that, remember I mentioned that we were looking for that to kind of happen with this system. Right now it's only on the eastern side, and all of its energy is derived from the latent heat exchange, like we talked about here, that's under the process of changing over to. So the warm ocean waters fuel these storms, so when it moves over the Gulf of Mexico, we'll start to see that more. And the winds are a little more concentrated right around the center. You see that with hurricanes and tropical storms. You get close to the center, the stronger the winds are. You get those wind fields. Also, we've also unlocked a few assets from the National Hurricane Center. Today is the first scheduled Hurricane Hunter flight into the storm center here, and they're probably going to send up what they call the WP-3D Orion. Now, there's two of these. There's Kermit and Miss Piggy. One of these will go out there, and they are just chock full of some really cool instruments to get a better feel of what the storm is doing. They deploy something called drop wind sondes. These are these little computerized GPS locators that they drop out of the back of the plane. They fall through the storm, and they give you various temperature, pressure, wind readings as they fall to the surface there. So that gives you a general depiction of the storm makeup. Also, they have dual radar systems. They're left under the fuselage and tail Doppler radar. And when you combine those two, they almost give you an MRI scan of what the storm looks like, both vertically and horizontally. And I think the coolest piece of equipment on this is something called a microwave radiometer. And what this does is it shoots an image down through the clouds to the surface of the ocean, and it picks up the radiation that's emitted from sea foam on the surface of the ocean that's kicked up from the stronger winds. So it gives a sense of how strong the winds are based on that. Pretty cool. They also have another aircraft in their arsenal here that may go up, may not. This is a high-altitude aircraft, the Gulfstream 4, and it flies over the storms, deploys those drop sondes like we talked about there, GPS located as they fall through. It's also equipped with a tail Doppler radar, and this helps to determine the intensity. This will likely be an aircraft deployed probably later on in its evolution after it gets maybe closer to the coastline. I think they're probably going to send out the WP-3D Orion, though. That flight is scheduled for later on this afternoon. Also, if they do get out there and they determine that the storm has formed, they'll fly again every 6 hours. If not, they'll give it another go with a scheduled flight for Saturday morning to see if it gets better organized in the next 24 hours or so. So here's how things look on the computer models. Right now, it's got winds around 35 miles per hour or so, and it's categorized as an invest 9DL. We talked about that in another video, why it's called an invest and what that means. It's just short for investigative area, pretty much, as we're just watching this. And the 90 is just a number that goes from 90 to 99, and they recycle after it gets on through the 9 different storms. And the L indicates the basin we're looking at. L stands for Atlantic Basin, and then sometimes they use E for the Pacific Basin. So right now we're in the Atlantic, we're using L. Each line you're seeing here is a different run of a different computer model. There's a whole bunch of them here, and there is a good consensus on taking this storm to the north, through the Gulf of Mexico, over warm waters for several days. So a lot of latent heat energy there and available to help that storm grow and strengthen, and making landfall somewhere along the Gulf Coast, anywhere between New Orleans and, say, Panama City in Florida. Likely that center point, that median of all these, right around Mobile Bay. And at that point in time, some models have it at a high-end tropical storm or even a Category 1 hurricane. Some of the higher-end models. Those are outliers, though. So we'll watch it, though. A lot of indications are with this warm water over the Gulf of Mexico and relaxed wind shear, the storm could overperform, but right now it's kind of messy, and it's really got to get itself together in the next couple of days to see that happen. So let's compare the two long-range big models that you've probably heard about a time or two. This is the GFS, the American model, and of course the European, that's pretty much the king. It just has amazing computing power and can really nail storms pretty well. So let's compare it as we go out into the future here. And you'll notice the red is going to be the European model. The yellow is going to be the GFS. Here we are into Saturday night at 10 o'clock. It's now over the open waters of the Gulf of Mexico, starting to strengthen. Something I want you to notice here as it gets closer to the coastline. Here we are Sunday evening at 6 p.m., probably 100 miles off the coast of Florida. And the European model, these lines that you're seeing here are isobars, or lines of equal atmospheric pressure. When they're closer together like that, that means the gradient is steeper, hence the stronger the storm. So the European paints a much stronger storm here. Meanwhile, the GFS, the American, is a much broader low as it heads towards the coast. And the European even strengthens it further before it makes landfall, or just off the coastline here at Monday in the evening on Memorial Day. So it's slowing it down considerably. The GFS is well on shore at that point, and then eventually it gets stuck under a ridge of high pressure, and that's going to help it just kind of sit here and stall, bringing a lot of rain to the southeastern parts of the United States. It's not going to move inland, get swept up by a front, and then get pushed out to sea. It's going to stick around for quite some time. So I want to show you something new here. I haven't brought this up in any of the videos yet, but this is from NCAR, and this is a model guidance that lets you talk about the intensities, right? So the models can show us where the storms are going, but this gives us a feel for how strong it's going to be. So on the x-axis on the bottom here, you're going to see the forecast period going out in a period of time. And then on the y-axis, going up and down vertically, you're going to see the intensity and wind going in knots. But you notice each line here is a different computer model. And once you get into that gray area you're seeing here, that is tropical storm status and higher. And eventually, once you get to the top of that gray area, it goes into Category 1 hurricane. So most of these models now are putting it at a tropical storm strength, some a high-level category, or high-level tropical storm, I should say. And even one, an outlier obviously here, puts it at a low-grade Category 1 hurricane, just barely, with winds of 74 miles per hour sustained. So it may sound odd talking about tropical systems in May, and we aren't in hurricane season yet. We're about a week out, and we compile all of our named storms pretty much within that 6-month season, the majority of which are going to be in August, September, October, the peak being September. So 97% of all named storms happen within that season. So there's that 3% that happens outside of it. And believe it or not, Memorial Day weekend isn't immune to having tropical storms. In fact, in the the recent past, I should say, in 2012 and 2016, there were 2 different tropical storms over Memorial Day weekend. We first had Beryl that brought a ton of rain to the southeast, and then we had Bonnie that was a tropical storm and weakened before it made landfall in South Carolina to a tropical depression. But you notice both of these were off the southeast coastline and developed in the southern parts of the Atlantic. So the origin of what may be Alberto is a little bit odd, considering we don't usually see development there this time of the year. So that's going to be something to watch. So we'll watch it closely as we go through the weekend. Till then, enjoy your weekend. Have a safe holiday and enjoy time with families and friends. And if you want to ask a question about what's going on in the tropics, want an update throughout the weekend, find me on social media. Ask a question. Shoot it on over. On Facebook, meteorologist Tim Pandages. You can also find me on Twitter at 13 Tim Pandages.